Okay, let's look at this one. According to a survey, 23% of residents of a country 25 years old or older had earned at least a bachelor's degree. You are performing a study and would like at least 10 people in the study to have earned at least a bachelor's degree. Okay, question A. How many residents of the country 25 years old or older do you expect to randomly select? Okay, so we recognize this being a binomial. Recall that the mean for the binomial is n times p. Well, what do we know here? So notice that we are trying to find n. That's what we're looking for. How many residents do we want? So what do we know? Well, we certainly know p, right? The probability is 0.23. So I'll just start labeling some stuff that I know. 0.23. And we would like at least 10 people. So that is my mean. That's sort of my expected value there. So I'm just going to plug in what I know. So I'm going to say 10 equals n times 0.23. Okay, sorry about that. Had an error there. N times p, so n times the 0.23. Now we're solving for n, right? Using a little bit of algebra. We're going to divide both sides by 0.23. Those cancel. And then you can use your calculator to say 10 divided by 0.23. And you do that, you get 43.47, and you round that up to 44. So you end up getting 44 as an answer. Okay, so again, our answer here is 44. Now the part B is a little trickier. Let me erase this stuff. Okay, let's look at B. So we want to know the number of randomly listed residents with a probability of 0.937 containing at least 10 who have earned at least a bachelor's degree is, and then there's some number. Now we can see the answer here. Maybe I should have graded that out, but we're not going to know that. So how do we figure this out? So the probability, I start writing stuff down. What are we trying to find? We want probability of at least 10. So at least 10 means that x is greater than or equal to 10, right? So if I'm going to write these down, if I've got the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So how many do I have to select for this? So at least 10. So I'm looking for this right here. I'm actually looking for what number needs to go in there. I don't know what that's going to be. So how many do I need to select in order that I get at least 10? So in order to find that, oh, I can put 0 here. It's easier, as we've seen in easier lessons. This one's a challenging problem, but in easier lessons, it's easier to say, okay, rather than finding all those, it's easier for me to do 1 minus and find that. So if I do, this is the same thing as saying 1 minus the probability that x is less than or equal to 9. Why would I want to do that? Because my calculator and StatCrunch, as I recall, has a function that will give me this right here, the Binomcdf function, right? So if I do 1 minus Binomcdf, it sums up everything from 0 up to that number. If I know the n, this is actually what I don't know, right? The p, which is 0.23, and the x, which is this 9. It'll sum that up. Now, what do I want? This is the hardest part of the problem. Trying to figure out what you're getting at. We want an n. How many people do I need to select to have a probability of 0.937 that I have at least 10? I want to know what that is, so that this is 0.937. Well, there's a very complicated way to do it without using technology, but we're not going to do it that way, of course. It's just sort of a guess and check. A lot of students don't like that. But hey, that's what statistics is about sometimes, is sort of plugging in values to see what happens. So let's do that. I'll pull this around here. So I'm just going to put in 1 minus Binomcdf, second distribution. See, normally we know that, and we're trying to find the probability. But now we have a probability, and we're trying to find the n. I mean, this is what sort of a little bit of algebra, a little bit of statistics, except we're not going to be using algebra for this. We're going to use the technology. Here's what I don't know. I don't know n. So probably the easiest way to do it is just to kind of pick a number. Well, let's start with 50. So 50, comma, 0.23, comma 9. And press enter. Okay, that one I get 0.7436. So I need to choose a bigger one. Now rather than retyping that, you probably already know this little trick, I can press, let me pull the calculator up so you can see it. I can press second enter and it'll pull back up what I just did, so I don't have to retype everything. Let's try 60. Ooh, that's getting closer, right? I'm looking for 0.937. Pull it back up. Try maybe, we'll increment by 2 now. 0.9296. Okay. Let's do 64. 0.945, which is a little bit above, so I bet it's 63. Of course, I'm kind of joshing it there. I know it's 63. But this is sort of the process I would go through if I didn't know what the answer already was. We went from 50, we just kind of picked a guess. 0.937, a little bit of a rounding issue here, but that's okay. There we go. So the answer there is 63.